Well, hello, my eighth graders. I hope you're having a nice break. Ooh, they're now saying 6 inches of snow Saturday night. Oh no, what if we don't have school Monday? Oh dear. So, the topic you missed out on because of retreat has to do with this rule. If I have a product underneath the square root, I can break that up into the square root of the first factor times the square root of the second factor, or in fact, any radical, although we usually do square roots, and a few times cube roots. Well, the reverse is also true. If I have a radical of something times the same radical, has to have the same index, I can combine that to the product of the factors. So, if I had square root of 2, and I'm multiplying that to the square root of 10. Excuse me. There we go. Frog in my throat, I guess that's what they say. So you could say, hey, that would be the square root of 2 times 10, which is the square root of 20. Then I can simplify that to the square root of 4 times the square root of 5. And the square root of 4 is 2, so it's 2 square root of 5. So I can just get more stuff outside of the radical, in this case, square root. So if I had a square root of 3 times square root of 12, I'd say, hey, that is the square root of 36. Hey, 36 is a perfect square, so that'd just be 6. Now I can expand a little bit on this. I could write a 2 square root of 5, 3 square root of 10. So you'd say, okay, 2 times 3 is 6. Square root of 5, square root of 10 would be square root of 50. I'm cool, 50. Ha ha ha. So, 50 would be 25 and 2. Now I'm skipping a step here. Technically it's 25 times 200 square root, but I broke it up. And square root of 25 is 5. So it's 6 times 5 times square root of 2. So it'd be 30 square root of 2. Now notice we're not foiling because there's no plus or minus in between the terms. So if I had 3 square root of 2 times 5 square root of 6, so it'd be 3 times 5 is 15. Square root of 2, square root of 6 is square root of 12. 12 would be 4 and 3. Square root of 4 is 2. So it would be 30 square root of 3. So it's just a reverse of what we've been working on. Now I can expand this a little bit more. What if I had 2 square root of 3 and those things being squared? Now there's 2 ways to look at this. I could use the product rule of law of exponents. If a product is raised to a power, I raise both terms to that power. Excuse me, so it'd be 2 squared times square root of 3 squared. 2 squared is 4. Square cancels out, so you just get 3. 4 times 3 is 12. Or I could say, hey, when you have a square, you write it twice to make it nice. So it'd be 2 times 2 is 4. Square root of 3, square root of 3 is square root of 9. And the square root of 9 is 3. So it's 12, which I already said. Now, if I had this, square root of 5 times square root of 5 plus square root of 10, I now have a plus or minus in between. So I'm going to take this and distribute it to both terms. So it'd be square root of 25 plus square root of 50. Square root of 25 is 5. 50 is 25 times 2. I will write it down. I'm just going to give you the answer, but I ain't got to write it down. So it'd be 5 plus 5 square root of 2. So try 3 problems by yourself. Right now. Do those 3 for me, please, and then turn me back on. Okay, so 1 times 2 is 2. Square root of 3, square root of 6, square root of 18. So it's 2, square root of 9, square root of 2. And square root of 9 is 3. 3 times 2 is 6. Here we just square both terms. 3 squared is 9. Square root of 2 squared is 2, so it's 18. Here we distribute. 5 times 1 is 5. Square root of 6 and square root of 2 is square root of 12. 5 and 1 is 5. Square root of 2, square root of 2 is square root of 4. So 12 is 4 and 3. Square root of 4 is 2. Square root of 4 is 2 times 5 is 10. So it'll be 10 plus 10 square root of 3. Hey, my friends, that was fun. Have a good couple days off.